Welcome to a new tutorial on Gdevelop. For those that are not regular watchers of our tutorials, we have a long-run series on building a Contra Like game with Gdevelop. And when facing some difficulties with a specific part to the engine, we usually complement it with a focused tutorial. In this case we are approaching the layer system for camera follow and parallaxing, which in our tutorial gave us some headaches, as some of the elements were not working as they should have been or we were not understanding them correctly. In this video, we will try to give some insights on how the layer systems work, how we should use it to build correctly a camera following and parallaxing feature for our games. Most of tutorials on YouTube, when dealing with camera follow, are using it only with a layer. Plus, when integrating parallaxing, the way it get covered becomes very shady and really hard to understand correctly on how it should be set up, why it works in the way it works, and how you should use it correctly to get your parallaxing working. For this, and other reasons, it is why we have decided to do this specific tutorial. For Gdevelop, each layer is a different camera that can be set relative to any object in the world. So when we are creating a new layer, we are also creating a new camera that has its own independent configuration. This was the reason that, when implementing the follow camera functionality in the Contra tutorial, when the objects were in different layers, they were not behaving as expected, and had each of them different positioning on the screen. When thinking about parallax in Gdevelop, we can think into different ways to implement it. The first possibility is to have all objects on the same layer, and then managing the Z order for each of them while modifying the positions on X and Y, to implement the parallaxing. This has a drawback, as you will have to move each object in the same Z position to actually make the effect work. But it can work if we are using large sprite or tiled sprites to implement the functionality. The second way, and which is the most used, is by using the layer feature of Gdevelop, as to associate each parallax layer with a Gdevelop layer, and then managing the position of each of the cameras. This becomes easier, as we have only to worry about the position of the cameras. Let's see some of the possible parameters and ways we can use to implement correctly the parallaxing feature. Speed. The speed, at which depending on how far the layer is relative to the point of view, it should be moving in relation to. Size. Associated with the speed, the size of each layer in the parallax should be different, the slower they are, the smaller they have to be and vice versa. Color. Depending on how far from the point of view, the color of the elements in the layer will have to be different. When traveling in a train or a car, you can see that the objects that are closer to you are moving very fast, while the objects far away are moving slower, or in some cases, almost still. This is a perspective effect due to our vision. If we want to replicate it, we need to have all the objects in the farthest layer to move at a fraction of the speed of the point of view. Usually this is done by dividing in the speed at which the object should move by a factor of the distance between object or plane and the point of view. In our case, with Gdevelop it will be the parameter that we will use to affect the layer and camera position. If we think that for each layer of perspective that we want to use for our game, as a different image that will have to be displayed and moved on the screen to create the illusion of distance. Then, depending on how far they are from the point of view, and since they will move faster and slower, we will have to make them at different sizes, if we don't want to reach their limit while the game is running. As general rules, the further away from the point of view, the slower the layer or image background will move, and the smaller it will have to be kept seen at all times while the game is running. The closest to the camera, the fastest the layer or image will move and the bigger it will have to be to cope with the movement. If not in size, in repetition of patches of images. If the layer is in front of the player, then the speed of the scrolling will be multiples of the player speed, and the image will have to be even bigger, or we will have to use more images moving in and out of the screen to keep the illusion. Multiple images parallaxing. In some situations, the art assets being scrolled are not a large image, but part of images that can be repeated several times without any problem. These images are scrolled accordingly to the movements of the player, and when leaving the screen, they are usually moved to the overside of the window to restart the scrolling movement. Color. When dealing with parallax, there is something that sometimes artists forgot, And that is related to the fact that the color of distant objects is not the same as the color of objects near the point of view. As we move further away from the point of view, we will have more and more atmosphere between the object and our point of view. This will make the object look more washed out in the atmosphere color. In Earth usually, the color will be moving to a white pale blue. As we move close to the point of view, there is less atmosphere and the color become more saturated. This is also called atmospheric perspective. When coming too close to the camera, the objects will start to become very dark or black. Let's implement a small demo to see how all these factors come into place. Create a new empty project and then, a player and ground objects to be used. For the player, we can create a red box. For the ground, and since we are going to use a parallax effect, use the ground sprite of the art asset pack, for which you can find the download link in the description of this video. Don't forget to add the appropriate behaviors to each of the objects as to make sure they can work as a platformer game. For the ground, we will have to edit the hitbox as to make sure that the boundaries of the collision are set to the portion of the sprite where there is actually some ground. Let's implement the first camera follow event. In this case, it will be a smooth follow with linear interpolation. Add a new event and leave the condition blank. Add an action and select the action camera center X position. Set the modification sign to set to, and in the value type lerp, camera X, player X and a speed of 0.9, which will set how fast the camera will move to the X position of the player. Since we are working on the base layer, leave the layer value in blank. If you run the game, you should see the camera for the base layer following smoothly the player. Let's do the parallaxing. Open the Layers interface by clicking on the Layers button on the top bar, and add 7 new layers. In our case we have named them BK layer and a number that reflects the order of the layer from 6 to 0, being the background 6 the one that is the farthest from the player, and the layer 0 the one that is above the player. Reorder all the layers taking in account that layers between 6 and 1 goes below the base layer, and the layer 0 goes above the base layer. This will reflect that layers 6 to 1 are behind the base layer and the player, and layer 0 is in front of the base layer and the player. Based on what we have seen at the beginning of this video, we have just created also 7 new cameras that we can manage to track the game. This means that if we want to implement the parallax effect, we need to manage those 7 new cameras. But before that, let's actually create the world. Create 7 new sprite objects and load in them the remaining background layers and set each of them to the appropriate layer. So, sprite BK6 should be associated to the layer 6, sprite 5 to layer 5, etc. There is one exception. The art asset brings a sprite of trees that we have defined to be as the background 0, and to be in front of the player. When finished, you should have a game world built and ready to code. We have removed the camera following event and start from scratch, as to see the gradual progress. So let's add again a new event with a blank condition, and then an action, where we will choose the action set camera center X position. In the modification sign, select set to and then in the value, type player X multiplied by 0.05. Now, we need to specify the layer for which camera we are modifying the position. Select the layer that you have defined as to be the farthest from the player. In our case BK layer 6. What we are doing here, is that since the layer is very far, the modification of the position of the camera for layer 6 will be very small, only 0.5% of the changes of the player position. If you try to run, you can see that, when the player is moving nothing is changing, even for the last layer, as the changes are so small that they are barely seen. Let's implement the parallax for the next layer. Copy-paste the previous action and modify the value of the camera change to be 0.1 and the layer to be BK layer 5. Try it, and you can see that there is something moving slightly at the back for the parallax. Replicate these steps for all the layers up to the layer 1, which would be the one right before the base layer, with the following values for the change of camera value, 0.2, 0.3, 0.5 and 0.8. Re-implement the smooth camera follow player on the base layer with the lerp function, as seen earlier on. For the layer 0, that is above the base layer, use the value 2 for the camera change. Let's run the demo. And you can see that we have a great parallax in place. The only problem is that it is only working on the x-axis, and if we jump nothing happens. Plenty of games work like that, but this is a technical tutorial, so let's show you how we can implement the vertical parallax too. Copy one of the actions, and replace the action camera center X position, by camera center Y position, and then, where we have player X, replace it by player Y. Keep the other values as they are. Replicate the steps for the remaining layers and then afterwards run the demo to see what we have. We can see that we have a vertical parallaxing in place, but the layers are now out of place and more focused on the player position, which is not actually what we had in mind. How can we solve it? After having searched in a lot of places, we didn't find a correct way to do it, but by testing possible solutions, we were able to find that if you apply a linear interpolation on the y-axis too, and adjusting the speeds of interpolation based on the fact that, the further away from the player, the slower would have the interpolation to be, we were able to implement a solution that is working. To implement it, just add the lerp function to the value field of each of the actions associated with the y parallaxing, and setting as a value for the interpolation a decimal value that will be decreasing as we move toward the player layer. In our case we started with 0.5 and we ended up with 0.05, that if you remember correctly, was the same number that we used in the interpolation for the smooth camera follow. If you make the changes to all the actions associated with the vertical parallaxing and run the demo, you should see that now everything is working correctly with a smooth parallaxing happening on the two axes. You can play with the values and try to get to a configuration that you like best. Another change that you can do, is to apply lerps to the horizontal parallaxing as to make it also smoother. We hope that you have liked this video. If it has been the case, consider subscribing, giving a like and clicking on the notification button. If you have any question, problem or comment, don't hesitate in putting a comment and we will answer as fast as we could. See you in the next video, game developers.